Good morning, everyone. So yesterday we learned about reducer hook. So in React hooks, use state, use effect, and use context, use reducer. These important hooks you learned. So the difference we clearly know about it. And state related hooks, we are having these. These are related to state. How to configure the local state. Context is from parent to child, and reducer is for. Yesterday we learned reducer is used for global state. Global state or what? Application state. What is the purpose of application state? The purpose of application state, it allocates a global memory, and that global memory is accessible to all sessions. And the advantage here is it is predictable memory, it is debuggable. Debugging, as I told you, at large scale, in the next level when we do one small application, we will implement this with a large scale using a concept called Redux. So at smaller scale, you want to maintain application state, then you can go with reducer. At higher level, you can go with Redux. The alternative for this is Redux. So these are related to state. How do we maintain the state and work with the state? Next important, we have some more hooks. These hooks are good to learn along with some backend databases and all. We will create one communication with the backend databases and we will use them also. So the other hooks, how to handle them and what is the purpose, we will see. Actually, you already learnt use ref. Use ref is a hook which already we discussed. So because we are learning all hooks at one place, we will just make a point about this. So what is use reference? It allocates memory. In that memory, you can store a function or value. What is the advantage of this memory is it is intended to use in the process. If any value or a function you want to use for a process, not for rendering, then better to keep in which memory? Reference memory, use reference. Already we saw this while working with timeout interval like functions. So a simple point I will give here. It configures a reference memory. It configures a reference memory where you can store a value or function. The reference memory allocates thread for value or task. Allocates thread for value or task. Thread is intended to run the task or keep the value in background process. In background process, the thread function or value is not intended for rendering in UI. Thread function or value is not intended for rendering in UI, user interface. So whenever you are configuring some value or function and you want that to execute in the background process as a thread and not meant for rendering the UI, then always you have to keep using this reference memory, and already we used it. So constant here thread is equal to use ref, and it is null. Thread dot current is equal to some value, or thread dot current is equal to some function. You can define some function or value. How to access? Actually, this is accessed internally. You can access with reference of current property. You can access and use with reference of current property. No need of any example. Already you learned debounce and throttle. In debounce and throttle, these two we implemented. So that is use reference. So what is advantage? Without use reference also, we can allocate some variable, we can allocate some state, in that we can store the value and use it. But if a process have to use it, it will take time. So that is the reason reference memory. Actually, these reference memories use function pointer mechanism. Through the pointer mechanism, they can access the memory easily, fast than when compared to normal, right? So in our already examples, so we have our examples. So to make the execution faster, we already used these two in interval demo. In interval demo, already we are using use reference. In the use reference, we are using for two purposes. One is for the progress value, another is for the thread. What we done in one location, we are using a value to store. In another location, we are using a function. Set interval is the function. We already implemented this in our examples and we learned that. So already use reference we used in two situations. and implemented. I think we implemented in another one, stopwatch also, na? Here also we are using the same option. So here also we have to define the use references and implement. I think I showed you a slide show, carousel demo. Na? In carousel demo also, we are using this use reference for product ID and for the function to execute automatically. So we have learned this one. So already we used these use reference and we learned some examples on them. Already examples are given earlier. You can go through them. We are in debounce and throttle. We learned about use reference. So what is the intention is memory should be in such a way that it is fast. You can access fast for internal process. Actually, in JavaScript based technologies, to speed up the work, to perform the actions faster than normal, we use general JavaScript related concept also. Actually, what we do here, one more I will show you, which you can implement everywhere to make the access and function faster. So here the question is, so what are the techniques required? What are the techniques required for handling interactions faster than normal? What are the techniques required for handling interactions faster than normal? So generally, there are various techniques of handling interactions faster than normal. What are the basic techniques required is there are so many options. Generally in JavaScript, if you want any interaction faster, for example, the point I will show you here, we are fetching the data or we are accessing it, suppose. Oh, some problem is there. Right. So here, yeah. So here, suppose we are dealing with some data. We need to access some data A and it is 10 MB. So B is 2 MB, C is 4 MB, D is some 8 MB. Like this, we have some data. E is 1 MB like this. Now I need to access the data. So that means we need to read all from A to E in an order. When we want to read all A to E, all the values from A to E, we want to read them. Then usually what we do is we can use any loop iterations, map like functionalities, and we can access. Generally, what happens is a request will go to the first one, and for this 10 MB is there. Suppose 10 MB, it takes 5 seconds time to read 10 MB. Then what happens? It will wait until 5 seconds completed. After that, for 2 MB, it takes 1 second. For 4 MB, it takes 2 seconds. And 8 MB, it takes some 3 seconds. And for 1 MB, it takes like 500 milliseconds. So that means it is taking 500 milliseconds. That means total to read all these, how much time it will take? To read all of them, it will take 11 and of milliseconds, 11 and of seconds, 11 seconds, 500 milliseconds. But we can finish this in 5 seconds. It will take 11 seconds to read all of this. But in your JavaScript, you can finish this in just 5 seconds. How it is possible? It is possible by using promise, function promises. In JavaScript, you have a function promise. By using function promise, you can finish that. Or promise is actually the modern technique of designing. Now you can also use the async and await functions. By using asynchronous and await, you can handle this in a better way. This is used in modern programming everywhere. Angular, React, everywhere when we write functions, we can do that. Actually, what is promise and async? If you already learned in JavaScript, good. Otherwise, I will just explain, I will give an overview here. Actually, what happens in asynchronous technique? We will make a request for 10 MB. It is taking time. Then we will not wait for it. We will keep it in the background and we will request the second one and request the third one and request the fourth one, request the fifth one. A request will go for all of them at a time. Then what happens? Whichever request is shorter, it will come first. That means what happens? The response from one is ready first. Na? The response from this is ready first. After that, response from this is ready first. That means what will happen is, what is the maximum time taken to read? 5 seconds. That means within 5 seconds, these also finish. Within 5 seconds, because it takes 5 seconds. Within 5 seconds, all other completed already. That means by the time you finish one, all reading completed, they are ready. They are shown to you. This mechanism can be handled through promise. You can use promise or you can use asynchronous to speed up the work. Actually, these use reference and all, they are inbuilt using asynchronous technique, promises and asynchronous. I will show one example how it happens. Actual, the modern JavaScript uses this technique. The best example is, for example, you are using WhatsApp. Suppose in WhatsApp, somebody sent you a video at 7:40 a.m. and he sent a text at 7:42 a.m. and he sent a picture at 7:44 a.m. Now you are offline, and when you are online, suddenly when you are online, which one will come first? First video only comes, after that text comes, after that picture. In which order he sent, according to the time, in the same order it will come. Only the point is you cannot see the video, you can see the text. Video is still loading. Am I right? Video is still loading, but by the time you have seen the text also. That means to finish the video, to display the text that is sent second, is it waiting until video is finished? It is not waiting until video is finished. Actually, if it uses synchronous, what should happen? First video should completely load, then text should come. But you are able to see the text. What you said just now when I asked you the question, you said text will come first. Why? Because actually text is not coming first. You are viewing the text first. You are watching the text first. Because in order only they will send. You are watching the text first because it is lightweight. It is lightweight. And others are heavy. They will take time. Is text waiting for them to finish? No. It is executing along with them. This mechanism is called as what? Async. So in React or Angular or anywhere these days, we prefer using lot of promises. Actually, synchronously one after another, then we call them as callback. At a time they do, then we call this as what? Promise. Promise. So we have techniques. What are the techniques here? Right. What are the technique here is, so first one, you can use JavaScript promises. You can use JavaScript promises. So another option is you can implement async and await for functions. You can implement async and await for functions. So you can use JavaScript promise, you can implement async and await functions. So these already you learned, otherwise you need to know about them little bit. I will show with an example here. Actually, already you know the promises you learned. What are those? Already you learned fetch. Na? Fetch is already using a promise. It is already a promise. Fetch is a promise. So here another question. So what is difference between callback and promise? These are all actually JavaScript concept, but in every React interview, you will face these questions. Every React interview, 100 out of 100, 99% interviews of React ask these questions. Especially for fresher, these are very common concepts. So what is difference between callback and a function is actually callback uses synchronous technique, synchronous. Synchronous technique to handle interactions. Callback uses synchronous technique to handle interactions. synchronous technique to handle interactions. And promise uses asynchronous technique. Promise uses synchronous and asynchronous technique. So now if anyone asks what is synchronous, actually it is a blocking technique. It is a blocking technique where all other tasks in process are blocked while performing the given task. While performing the given task. That is synchronous. And what is asynchronous? So it is an unblocking technique that performs all tasks simultaneously at the same time. It allows to run the task in background. It allows to run the task in background. Actually, ref is using that. Use ref is using an asynchronous technique. In the background, it is maintaining a task and it is running the task in the background. If you want to create anything by yourself like that, then you need this technique. Actual the synchronous asynchronous method is that. So let's see how you manage this. In our React application, generally already you learnt about a promise. Already you have used a promise. Fetch is one promise. We have callbacks and we have promises. Now you can create a promise and you can execute the promise. Means everyone learnt in JavaScript about promise. No need to explain again. Okay? Or you want me to explain? You already learnt about promise. No need to explain. Everyone knows promises. Right? Tell something, man. Yes or no. Otherwise, I can skip. So I'll just give an overview then, right? So generally, because if you already learned, we can skip this. Actually, promises and asynchronous are regularly used, so we need to understand them. Generally, for who haven't learned, just I will give a point here. Suppose we have a function, some fetch data. That is a function. This fetch data function is expecting an URL. You have a success and failure. So actually, we are taking the URL. If URL is matching with some fake store something, if it is matching, then success function will execute, and this success function will return some data. Suppose temporarily I am keeping the data like some name and some price, some data it is going to return. So some name and some price. So some data it is going to return. Otherwise, it will execute a failure function, and it will send a message. So like unable to fetch, invalid URL, something like this we define. This is a callback mechanism. This is a callback mechanism. Now in this, two functions are there, success function and failure function. Out of these two, which one will execute? That depends on the URL. If URL is matching, success will execute. If not matching, failure will execute. So we have to use callbacks like this. Fetch data. It is expecting URL. URL we will take from prompt. We will say enter URL. After that, it uses a function. This function will collect the data that comes as a response. That means you can say response. That response data, we can print it. Suppose console.log, I am printing the response, whatever coming. That is the function that executes on success. That means fetch data have a prompt. It is having a function on success. You have another one, comma. You have another function. This function will get the error. And console.log, it will return the error. Whatever error it gets, it will return. This is a callback technique. In this callback technique, what happens is, while reading this data, as of now, we are having only two records. On success, it should read those two records. It will take some time for reading those records. So what will happen? Suppose there are 1 million records. In reality, we will have millions of records. To read all those 1 million records, it will wait until all records are finished. Once all records are finished, then final data will come. That data we will display. That means it will wait until all the records are buffered. They are all cached into memory. After that, it will release. We will give it. So what will happen now? Let's run this here. I will open the console also. This is a callback mechanism. So in this, it is asking to enter the URL, and we entered some URL wrong. Some wrong URL is entered. Then it should get us the data. Let's inspect in the console. So in the console, it is showing here invalid URL, unable to fetch. That error message it is showing. Now I am fetching the data. Let's refresh this. I entered fake store correctly. Then it has to get the data and display the data. And you can see it is going to get the data and display the data. Actually, I kept a debugging here. Sources. in the sources category. Let's remove the breakpoint not required. Now you can see in the console the data comes. That means it is going to fetch the data and display the data. So if URL is wrong, then it is going to display unable to fetch. And when URL is correct, so fake store, then it is going to get the data and display the data. This is callback mechanism. In callback mechanism, what happens? It executes one function on success. It executes another function on failure. These days, we are not using this very much. This is not recommended very much. But you will see that already so many JavaScript projects and applications in the background, they are working on this callbacks only. In modern advanced projects, we are using alternative. What is that alternative? Promise. We are not using this mechanism. Actually, lot of libraries changed also. People who learned React 5 years back, 4 years back, or people who learned JavaScript and other JavaScript technologies 2-3 years back. Now, recently, they ping us, they send a message saying that, sir, 2 years back, I learned React from you. And when I practiced at that time while learning, it worked properly. Now I am again trying the same after few days, but now recently it is not working. Why recently it is not working? Because recently majority of JavaScript libraries, they changed the library from callback to promise. They converted all their callback functions into what? Promises. So their syntax changed now. Promise syntax is different, callback syntax is different. You will find lot of internet tutorials, online tutorials, which are published 2-3 years back, and you are following them now, then you will face problem because they are using callbacks. But now we are not using callbacks. We are using what? Promise. Let's see how the promise works. This is an example of callback. I will just give you an example here. This is example of callback. Huh? This is example of callback. Callback means you will have so many functions. Which function to execute, it will decide according to the situation. And when it is executing the function, if it takes time to execute, it will wait until it is finished. And while it is executing the function, all other functions are blocked. This mechanism is called as what? Synchronous blocking technique. That is the concept of blocking. We have asynchronous technique. Asynchronous technique means same example we will convert into promise. Let's see. In JavaScript, how do we create promises? We have to use a function fetch data. This time it is a promise. It is a promise. JavaScript provides promises. These promises are inbuilt asynchronous. Inbuilt asynchronous. Actually, promise uses a callback function. This function will have two options. One is resolve. Another one is reject. Resolve is a function that executes on success. Reject is a function that executes on failure. The speciality of this promise is it is designed with asynchronous. Direct asynchronous also I will show you. It is designed with asynchronous. What is the advantage? When a function is being executed, if it is taking more time to execute, it will not block other tasks. It will keep that in the background and it will do other tasks, so that it saves a lot of time and it will be faster. So here I am taking an URL prompt. I am asking for enter what? URL. And here, if URL is matching with what? Fake store, then resolve function should work. And resolve have to send us the data. That means we are sending the data. We are sending the data. Same, something like this we are sending. Some two details we are sending. And price. We are sending the data like this. And else what should happen? We have what? Reject. Reject will send the message. What is the message? Invalid URL, unable to fetch data. Something like this we will do. Now, how the promises are executed? We have to use fetch data because it is a promise. Promise is executed by using then. Every promise will have three functions. Then, catch, finally. Then is a function that executes when it is success. And catch is a function that executes when it is failure. And finally will execute always. So then is a function. This then uses a function. Actually, this then function gets what? Response. And that response we will put console.log. We will put the response. Then we have another function. What is it? Catch. Catch is a function that executes on failure. It will get the error and it will report the error. Console.log and it will report the error. Finally is a function which executes always. On success, on failure, it will execute always. Console.log, we will put a message saying that program end something. Program end, memory cleared or something. The action end, request end. Suppose I given request end. Request end. Now, what is the point here is this time we are using a promise. Promise is a faster mechanism of executing your tasks. Now you see here, I will run this. Enter URL, some wrong URL. It will get invalid URL and request end. You entered the correct URL. What is it? Fake store. It gets the data and it will show. Technically, this is faster when compared to the normal callbacks because it uses an asynchronous technique. When you are working with large amount of data coming from backend, lot of processes happening, you can see the difference also. As of now, we are having only two records to get the data and use it. We cannot find much difference. For example, I will show you here. I will copy this one. This is related to asynchronous. This is an example of what? Promise. This is example of promise. Actually, I will do one thing. Let's copy the previous example. This is a callback example. Okay. Let's go here. I will go to network category. This is network category. I will go to the network category in the debugger. Let's change our program. I will put the previous one. The previous one is I kept the callback one. I will save this. I will refresh here. And you see it is asking enter URL. URL is what? Fake store. Then it gets the data and display. And you see it has taken 9.24 seconds. 9.24 seconds to finish the functionality. And you see in the console data is ready. But in the network, it has taken 9.24 seconds. Okay, let's remove this program. And let's go to this one, promise one. I will go to the promise and put the promise one here. And now what I will do, I will refresh once. Then I am entering fake store, enter, and you can see it is 4 seconds only. And data is there, data is same. But in the network, you can see it takes 4 seconds time to execute your task. It is fast. So remember, in web development, already you learned CSS and all these things. Even 1 millisecond matters. In real-time project, 1 millisecond difference is coming. That's a big issue. You are thinking about seconds. Even 1 millisecond difference is there. We will implement the 1 millisecond faster one, because this becomes a huge issue later when it goes live. So asynchronous function is faster when compared to the synchronous, because synchronous uses which mechanism? Blocking. Asynchronous uses which mechanism? Unblock. When it is performing your task without blocking the other task, it will execute them. It is fast. So promises uses this mechanism. Promise use this mechanism. I hope you understood that. And actually, promise uses so many things. Means when you learn in JavaScript, you will learn actually promise have multiples on then. That means on first time success, it will get the data. On then we can perform so many. We can get another function. We will put a message console.log. We will put a message that data is ready to display like this. There can be multiple then blocks. There can be multiple then blocks. So on success, you can execute multiple. And what is the specialty is it will perform these two at a time. It is going to perform all these at a time. For example, see, one function is getting the data. Another function is data is ready to display. Okay, I will use another then function. That means multiple then functions I am writing on success. So console.log. So and data displayed successfully. These messages I am giving. Now observe carefully here. I will do one more extra work. The first then function. This is the first then function. I am declaring var now is equal to new date. So what I am doing, I am getting the date. And here what I will do is response is coming console.log now dot to get milliseconds. I am getting milliseconds. Milliseconds. I am getting milliseconds. Now the same thing let me do everywhere. That means I will copy this second function also declaring a date. Third function also declaring a date. In all these three functions, I am displaying the time. Observe carefully now. I will go here. I will refresh, enter the URL fake store, and observe all function executed in the same millisecond. All executed in the same time. Actually, we have three functions. What is first function? Get the data. Second function is data is ready to display. Third function is what? Data displayed successfully, but three executed at a time. I am tracking milliseconds. That means within a millisecond, it performed all three tasks. Actually, if it is synchronous, what should happen? First task, after that, second task, after that, third. Actually, when you learnt about JavaScript fetch method, you learnt about JavaScript fetch. Fetch uses what? URL. After that, what it uses? Then. What this then function will do? Then function will get what? Response. After that, you remembered this response will convert into what? JSON. After that, what? Then we will collect the data. This data we present now. Do you know actually what happens? Suppose this data is having 100 records. That means 100 records are present. Now, what happens is the first record is converted into JSON. Like that, how many records need to be converted into JSON? 100. After converting all 100 records into JSON, those records are sent into data, into the second. Understood? That is if it is synchronous. But do you know here what happens? The first record it is reading. After reading the first record is converted. After converting the first record is sent here. Second record it is reading. While reading the second record, first record already sent. If it is synchronous, what will happen? It will wait until all 100 records come. After all 100 records, it will send it to the second function. But now what it is doing? In one block, it is reading. In another block, it is converting. In another block, it is displaying. All are performed simultaneously at the same time. So it is fast. This is the mechanism of what? Promise. That's what actually JavaScript promises are for. In the modern JavaScript, everywhere we use these promises very much. And if you want to create promise, this is example of promise. I will copy this example. This is example of another one promise. Example is this. Now, if you want to create your own promises without a promise, how we can create our own promise? That you can do by using async and await. By using async and await. For example, let's do one thing. How we can do that? By using async and await. So let's see here a simple option here. We are writing a function, and this function get data. This is a function, and what this function have to do is it should return some data. Data is nothing but some array. It has to return some array. Array of objects. So like name. So this is one object, another name, like this. So many data it have to return. Actually, to read and return the data, it become little bit slow. Because lot of data it has to read one after another, it becomes slow. In JavaScript, modern JavaScript, to make it fast, what we do is we make the function as async. We make the function as async. After making the function as async, now this return, whatever it is returning, it is using await and return. So what is the meaning of this is, whatever data it is returning, it will not wait. It uses await. It will not wait. It will use await. That means while reading, it will not block other tasks. It will perform this along with other tasks. That means actually this, when you use async and await in your JavaScript, it is automatically a promise. That means you see what is get data now. That means I am using get data, and you can observe this get data is a promise automatically. You can see get data is a promise automatically. Have I written like a promise like previous? I haven't written like a promise like previous. Anything you write asynchronous is by default a promise. That is the reason these days generally people who don't know this clarity, right? what they do on YouTube channels, internet, websites and all, they will see that several people are writing async await in the functions. They ask, sir, will you teach async await also in React? That is because you don't have a proper knowledge on that concept. Actually, you are already using promises, hooks. These all promises and hooks are inbuilt, designed with async. They are all, promise means already they are async. You can make them asynchronous to make them little more faster. To make them little more faster, you can make them asynchronous. But actually promise itself is an async. So you see now, this is going to return the data. It is going to return the data. And what I am doing here, just I am using console.log. What is that? Get data. That is the data. Actually, this data returns everything. That means what it is going to do, it is going to return a promise. And you can see promise on fulfilled. It is going to return the data array. Actually, it is a promise. That means this is a promise. And how the promise will return the data? By using what? Then. By using then they will return the data. If you created an asynchronous function, how to run that asynchronous function? Actually, if it is not a asynchronous function, you directly get data will return an array. Na? When you use get data, it directly returns an array. But this time it is not normal function. It is an asynchronous. Then how to use an asynchronous function? Get data dot what? Then. Then means on success. On success, you have to collect the data. And that data we will print. Console.log, whatever data comes, we will print. And you can see that it is going to print the data and show the data here. It is going to get the data and show the data here. That means actually I haven't created like a promise. I just created normal function with async and await, and it automatically became a promise. In my previous example, what I showed, var function name equal to what? Promise. But I don't need to write like a promise. If I write async await, JavaScript knows that it is a promise. That means many people have an habit of directly writing asynchronous function like this. But actually not required. You create one promise, through promise you can access and use it, right? So we can handle this functionality. Now you can implement this everywhere. I will copy this example. This is an example of what? Async and what? Await. Now you can implement this everywhere. Wherever you have handled the functionality, everywhere you can manage this. I will show some example also. For example, direct fetch data I will show here. Then we will implement in our React. That means you learned fetch na. What fetch is doing? Fetch is fetching from any API. https:// what it is? fakestoreapi.com/ what? Products. It is fetching all the products and it have a then uses a function. This function will return what it will return. It will get a response na response, and it will return response dot what? JSON. After that it will use another then function, will get the data is nothing but products. We have to read all the products by using a map mechanism na. That means products dot what? Map. Map will read a function. It will read what? Every product, and every product we will print document dot write. I will print the product dot title with a break. Just I am using this. It is already a promise. It is already asynchronous. And observe carefully. Let me turn on the network, and I will turn on the network here and I will refresh it. Then it is going to get the data. And to get the data and display all the data coming from here, you can see it is taking how many seconds? 718 milliseconds. It is taking 718 milliseconds. Already it is asynchronous. Already it is a promise. But see what I am doing now. I will make this then function as async function. That means the internal function of the promise also I made as asynchronous. Then this response have to what? Await. And the function which is reading the products, this is also an async function. And what it has to do? It has to print this message na await. That means this is an async function. That means what it is, not this one. We will use this one. What is the map? You see this map is again, what is it? Async. And what it has to do is it has to print these details. That means I am using an await to print. Actually, it should return value. That means already these are asynchronous. They are asynchronous, and I am using async and await to handle the functionality. Async and await to handle the functionality. Usually what happens now is when I refresh this data, it is more faster. More faster. Already it is faster, and we made little more faster in rendering. That means what we have done previously, it was how many? 700 milliseconds. That means we made little fast. Actually, it will cache your data and it will use the cached data. So this is more faster in rendering. That means it is more asynchronous. Already it is asynchronous. You don't need again asynchronous, but we can do. That is the reason you will see people know that they are already working with asynchronous technique, because React.js is completely built with promises. Every hook, every concept they designed using a promise. But why React developers again should use asynchronous techniques? To make little more better in performances. More better in performance. So this is the concept, how you can manage your functionality. That this you can implement everywhere in your React. This is another example of async and await. Async and await, another example. Now you can implement everywhere. What is the concept here? Let's go into your examples. What is the example actually? So you see, reducer is a function. Reducer is a function. What this reducer function is doing, it is returning viewer count. Now I want this to more better in performance. Then I can make this function as what? Asynchronous function. Then what is the result it return? It uses what? Await. By using await, it can return the result. That means it can return the result. And see, it says that it has no effect on this type of expression. Why no effect on the, you can write it, no effect, because already they are asynchronous. React is already using what? Promises and asynchronous. Asynchronous. So that is the reason everywhere we don't need to use this. Everywhere we don't need to use this. Right? But in various occasions we can use it. Wherever it is not asynchronous, you can configure it as what? Asynchronous. Later in so many examples also we will implement that. We can use that and we can handle it. Actual what it does, suppose you have a join click, exit click functions. These are events na? On click, join click, on click, exit click. That means you can configure as what? Async. And it uses await to dispatch. It uses await to dispatch. That means it is using an asynchronous function, async function, and it uses what? Await. And usually React already says that, because you are using modern React, it already says that that means there is no effect of this type of expression. No effect. That means actually there will be a smaller functionality effect will be there, but that is not very much complex difference. That's the reason it's not required everywhere. Later in various examples, I will show you how we can implement that, right? Already in other examples where you tried this fetch, you can use it. I think where we used fetch, I used fetch in weather API. Yeah? Weather API, we used what? In weather API, we used Axios. Na? Yes, Axios, we are using a response. So this response dot data, right? For example, you see this, then it is getting the data, it is sending a response. Here you can make it as what? Async. This as response is async, and this data, whatever it is returning, what it is, await response dot data. We can use it. That means whatever the weather data it is collecting, it will get it in a asynchronous. That means it is more fast. It is more fast. That means whatever the response, because this is a function. Actually, this is function parameter. This is function parameter. To that function parameter, we are applying what? Async. And whatever data it is returning, we are showing using await. That means we are saying that fetch without waiting. Fetch without waiting. We are doing that by using this technique. You can implement in this example. You can implement in this example. And you can implement everywhere. For example, it is fetching the value from a text box or a drop down. If it is fetching the value from a text box or drop down, what you can do? Async. The value it is fetching, you can use as what? Await. You can use as await. That means without blocking, you can fetch the data and we can use the data. So this is the concept. So I will show here. This is which one? Weather, na? Yeah. That means all in your React examples till now, whatever you learned, wherever you are fetching data using Axios or fetch, everywhere now you can add an async. Every event also you can configure as what? Async. What functionality it should perform and all. Actually, we haven't designed it for async. Suppose I entered here, so Hyderabad, and I click on search, then it should get that. You can see this is little faster when compared to previous. If you have practiced this earlier, it will take little time in getting the data and showing, but now it is better. We can improve the performance in handling the data, that is done by using what? Asynchronous. So whatever examples you tried, you can implement with async now. That means where to use async, generally when to use async. So you have to use async in this situation. Where we are using async, when you are writing some event, this event is collecting the data from your drop downs text boxes. While collecting the data without blocking, it has to collect the data. That means little faster. Then make your event as what? Async. Every event function you can make it as async. Collect the data by using which method? Await. And when Axios is fetching the data from particular URL, when it is doing it, then what we are doing, you are using async, get the response without waiting. That means actually this then itself is a promise, na? Then itself is a promise, but inside then there is a function. I made that also as promise. That means I made this also as a promise. That also as a promise, so that it can return in a faster way, right? You can implement this async and await in every place. You can implement in every location, right? This is example here. I will copy this example which you already learned. This example already you know, but just I am using example. This is what? Weather API, async and await. I'm using async and await. Actually, it is using Axios. Axios is already a promise. Already it is a promise. So this is very, very important in modern JavaScript. And you will find in all React applications everywhere people using these asynchronous methods very much, right? So what is callback? Callback defines functions that execute in a synchronous. And to make them faster, we have a promise. What promise uses implicitly? Async and await. Explicitly, you can create promises by using a predefined promise object in JavaScript, or you can directly create a promise by using async and await. There is a promise object. By using that object, you can create promise, or you can create manually by using async and await. These are important. These are important everywhere in modern JavaScript and React, Angular, everywhere you'll find this. Now to make the interactions more faster and better, you have other hooks called, we have hook called use callback and use memo. We are having the hooks called use callback and use memo. Actually, use callback, use memo are available from React 17 version. But recently in React 19, officially they announced that you don't need these anymore. You don't need these anymore. You have better than them. In the new version of React, they officially announced that callback and memos are not required anymore because we already have a solution for that internally. You don't need to implement them. But almost every React interview will ask you question about what is use callback and what is use memo. These are all interview questions. Because already people are using them, then you have to understand what is difference between them. So we need some examples to implement this callback and memo. That means if you have good data, through the data you are handling the interactions, then callback and memo are important. I will first explain the syntax. We will implement in an example with data later. First, we will understand the process. Actually, what is the concept of use memo is? Use memo is used for memorizing your data. Memorizing data is nothing but you can simply say that it is caching the data. What is advantage of caching? What is caching? Caching is required to save round trips. You learned now what is round trip? What is round trip in web applications? What is round trip in web application? Round trip is a mechanism where a content is requested every time from server. Every time from server. And we can save round trip. Actually, this you learn in general. For example, when you are learning your HTML, you know in your HTML, you have two sections, the head section and the body section. Can I keep title in the body section? Of course, you can keep title in the body section. You can keep link script in the body section. You can keep, there is no problem. Right? Now, the point is here, I can write a script in the head section. I can write a script in the body section. That's possible. Now, generally what you learned in HTML about this, when to keep in head section, when to keep in body. What is difference between head and body section? Any content you keep in head section of a HTML page will be saving round trip. That means any content that you kept in head section, when first time we request, it will load into memory and it will be in the memory for some time. You request it again it will come from the memory. It will not come from the server. This is called as cache. Round trip means what? Every time it comes from the server. Your request, every time it comes from the server. What generally people tell you, title must be in head section only. No, that's not correct. Title can be in body also. Script can be in body. So in real world projects, in some occasions, we keep title in body also. When to keep title in head section, when to keep in body. For example, in body section, I kept the title saying that index page. And when I run this, the title is working for this. You see, title is working now. So if anybody says that title should be in the head section, that's wrong. That's wrong. You can keep in head or body. Then when to keep title in head? If title is fixed and it is same every time, then always keep in head section. If title is changing regularly according to the request, then always keep in the body. What is the difference is round trip actually. Already HTML people, you learn that. Generally, what is the concept of round trip means? Suppose you are having a server. And now what happens is we have two types of content. We have head section, another one we have body. Now what happens is this is the browser related memory. We have a browser memory. Now whatever you kept in head section, it will first go into memory. Whatever you keep in head section, it will go into memory. And from memory, it is delivered to the server. If server wants that means in the client machine, it is taken. If it wants again, that means what happens here? This all I will keep here. This is memory of our browser. We will use our browser. This is our browser memory. This is browser memory. Now what happened is the browser memory, this content, let's say this is browser memory. Now what happens is from the memory, it will come to your browser. If I want it again, then what will happen? It will again come from which location? From the memory, it will come again. Any number of times you are requesting, then obviously it will come from memory again. This is fast. Actually, if you keep anything in the body, what will happen is this body content directly will come to the browser. The body content directly come to the browser. If I finished using it, I want body again. Then from where it will come again? It will again come from the server. This is called as what? Round trip. That means every time when you request anything, it is coming from server, then it is called round trip. If it is loaded in memory and it is coming from the memory, then it is saving round trip. When you keep anything in head, remember, anybody told you that in head section we should have title, link, meta like options? That's wrong. You can keep them in body also. Right? You can keep them in body. If anybody asked you in interview what is difference between head and body section of a HTML page, your answer should be content in head section are used by saving round trip. Content in body section always load using a round trip. If any content you want to save round trip, then you have to keep in which section? Head. Remember, without head section, directly you can write everything in body. Title, link, script, style, everything will work. Only the problem is body loads every time from server. You want frequently used data in the same way every time, then better write them in the head section. So this is very important to understand. So what this use memo, use callback are going to do is they are going to use your cache memory, and if frequently used data, then they will cache and they will save your time without getting from server every time. That means if some data is very frequently requested, they will cache your data, they will get the data and show the data. That will save the time and improve the performance. That is the job of memo and callback. What is difference between these two, we will see. What is callback and what is memo. That we'll see in next session tomorrow. Right, in tomorrow's session, we will discuss about that. Today we learned very important, that is how to handle asynchronous requests. In React, everywhere you can implement this asynchronous now, promises and asynchronous. Tomorrow we will discuss about memo and callback, how to use them. Okay.